right now our user has the ability to add a bunch of to-dos. So we can go in here and add, and add, and add, and you get the idea. But right now we have absolutely no ability to delete any to-dos or to even edit any of them. I'd really like it if you spent a little bit of time to work on a little addition or a little extra feature to add into this application. Let's take a little bit of time to describe and tell you a little bit about what I would love to see added in here. So let's start by looking at a mockup. Right now we've got that file menu dropdown and it has the option to add a to-do or quit from the application. I think it'd be really fantastic for our users if we added another option to that menu to give our users the ability to clear out the current list of to-dos from the entire list. So if a user opens up the file menu and then clicks on clear to-dos, I want to see this entire list just poof, disappear, go away, totally empty out. So this would be really fantastic if you gave it a shot on your own. Let's spend just a little bit of time to make sure that the directions here are nice and clear. So whenever a user clicks this thing, we want to clear out that list. To me, that sounds like we want to do some communication from the Electron app down to the main window. And we probably want to communicate some type of event there. Say something like, hey, clear out the to-do list, please, or something like that. So it sounds to me, or I kind of get the feeling that we'll want to make use of the IPC system for this additional feature. Then the other thing I want to mention to you, just in case your HTML is a little bit rusty, you can clear out all the children or all the descendant nodes of an HTML element by calling inner.html and setting that equal to an empty string. So really that's supposed to be an empty string right there. Like, you can't quite tell from this text right here, but really you set the UL's inner HTML equal to an empty string and it should delete the entire list. So there's no need to get too fancy here. Just clear out the UL's inner HTML and you should be good to go. So I encourage you to pause the video right now, or we're going to take a break. So we'll say, feel free to take a shot right now. If you don't feel super confident about doing this on your own, hey, don't sweat it. Just continue in the next video and we'll walk through the process together. So give it a shot and I'll see you in the next section. Now that we've got one project under our belts, it's time to start looking forward and think about the next project that we're going to be working on. So let's take a look at a mock-up for the next project that we're going to look at. Now I'm going to tell you right now that this application is going to be a little bit on the boring side. Yes, it is going to be your classic to-do application of sorts. However, all the time that we spend on this application will not be really focused around the to-do side of things. It's going to be around some very common areas of polish that are required in Electron applications. So there's some very interesting aspects of Electron development that you don't really think about until you start to get into these really weird gotcha situations. And that's going to be the real focus of this section. We're going to figure out how to deal with the flow of an application in the Electron world. And so really the to-do application that we're building here is just kind of a shell, or just to say, yeah, we're actually making some type of application as we go through this. Okay, so let's walk through the mockup and figure out how this thing works. So we're going to have a little bit of a flow here as we go through the application. When a user first boots the application up, they'll see the window and they'll see just the text, my to-dos, or something like that. By default, they probably won't have any to-dos, so they'll probably see something that looks like this. But you can imagine that after we add a couple of them, maybe we'll have like to-dos on here that looks like so. And you'll notice that on the screen, there's no button or anything like that, or input to accept a new to-do. So how are users going to add additional line items on here? Well, check out the file button up here. So this file, yeah, it looks like a drop-down kind of thing, but it's really intended to be the same kind of drop-down like this, or menu selection at the top of the screen that you see right here with Balsamiq mockups. Now it's worth noting that on Windows versus OS X, the location of this drop-down menu is going to be slightly different. If you're on Windows or you've ever used a Windows machine, you know that the actual window that you work with contains the file, edit, view, all those traditional menus at the top. But on OS X, we get this omnipresent status bar at the very top that houses the same exact menu. And so there will be a couple of cross-platform considerations that we're going to add as we start to think about how to access this file thing up here. Anyways, back to the file itself. So if we click on this drop down up here, which would essentially presumably be the same as doing this right here, I want to show the user two buttons. So I want to show them a button that says Added To Do and a button for them to quit from that menu up top. Now here's the real twist. When a user clicks on Added To Do right here, I want to pop open a completely separate window that's going to allow the user to enter some text, submit it, and then see the to-do pop up on the screen behind it. So again, all this might seem like, yeah, you know, a little bit boring. It's a to-do application, I know, and we only really have the ability to add to-dos. We're not going to do anything around deleting or editing them. But trust me, as we go through this, we're going to hit a ton of little gotchas that are really necessary points to point out about Electron if you're going to start building any serious applications with it. So again, the to-do side of this thing is not the focus. The focus is some of the difficulties that come around adding additional windows or showing a menu bar on the application window. Okay, so let's take a quick break, and then we're going to come back in the next section and start doing the setup of this application and then dive right into the implementation. We just finished generating our new project and installing Electron as a dependency. I've taken the liberty of opening up my code editor inside this directory. So here we go. I've got nothing in here except for the package.json file and the node modules directory as well. Before we start creating any JavaScript files, let's set up a script inside of our package.json file to start up Electron. So I'll open up package.json, and I will replace my existing script section with a script to start up Electron, like so. Again, recall that you do need to use double quotes in here. Single quotes will throw an error if you use those. Okay, so that looks like just about enough that we need to actually run Electron. Now it's time to put together some of the boilerplate to actually create a new window, create our new app, and all that kind of good stuff. So some of the code that we're going to write right now is going to look very familiar because it is going to look very similar to some of the code that we wrote in the last section. We'll start off by making our index.js file. At the top, we're going to require in the Electron library. We'll pull off our app, we'll listen for the app to be ready, and when it is, we'll create a new browser window. So let's require in Electron. Then we'll destructure off the app object. Remember that this is responsible for representing the running Electron process on our machine. We will pull off the browser window constructor, and both those are going to come from Electron. Now we can watch this app object right here and wait for it to issue the ready event, and when it does, we'll make a new browser window and then load up a HTML document into it. So we'll say app.onReady. Whenever it's ready, we'll then take that as a sign that it's time to create our new browser window. And again, we're going to pass in an empty object right here. This object is used for specifying some configuration settings for the window, but in this case, we don't have anything in particular that I want to pass into this browser window. Now do recall that looking back at the mockups, it really appears that we are going to have two separate windows appear on the screen at a given time. And it definitely appears that this second window over here is a little bit smaller and better shaped than the other one. So when we put together the code to create this second window, we will specify a couple options in this object right here to specify the actual size of that window. But that's something that we'll get to in just a little bit. Remember how we traditionally, or by convention, will assign the browser window to a variable. Normally, the main window of our application, or the main browser window, will be assigned to the main window variable. Also recall the challenge that we ran into in the last section. We ran into an issue where we had a little bit of trouble with getting access to this main window variable because of the way that scoping in JavaScript functions works. If you recall, we got around that issue by declaring the main window ahead of time by saying let main window. This initialized the main window variable to be undefined. Then when the app became ready, we assigned the browser window variable, or excuse me, the browser window directly to main window. And this helped us get around some scoping issue because main window was previously defined inside of this arrow function. The next thing we're going to do is create a HTML document that will be loaded into this main window. And we'll just hook that up and then maybe take a break and get a better sense of where we're headed from here. We previously had a single HTML document, which we referred to as index.html. Again, looking at our mockups this time, it really does appear that we might have two separate windows inside of our application. So rather than referring to the overall window or the big window, the main window's HTML document as index.js, or excuse me, index.html, I think we'll give it a little bit more descriptive name and call it simply main.html, so that we know that it corresponds to the main window. So back inside of our project directory, I'll make a new main.html file, and then inside of here, we'll put a little bit of boilerplate just to get things started. So we'll give ourselves a head tag, we'll get a body tag, and for right now, let's just show an H1 that says my to-dos. So now back over inside of our application, we need to take that main.html file and load it up into our main window. Remember how we do that. We call main window .load URL and make sure that URL is capitalized. And then we'll pass in the file reference to that HTML document that we just created. Again, we'll specify it as a template string so that we can include the current working directory inside this URL. So we'll say look for the file. I want to use the current working directory, so dir name / main.html, like so. Okay, I think this is about ready to test at the command line and boot our application up, and just to make sure we're going down the right path. So back at my terminal, we'll run npm run electron to execute the electron script. It looks like everything boots up and we see the text on the screen, my to-dos. Okay, so this looks like a pretty reasonable place to get started. Let's take a break and then come back to the next section and start doing a little bit of planning on exactly how we're going to put this application together. In the last section, we spoke about the next application that we're going to be working on. So again, remember this is going to be a to-do application. The to-do app is really not the focus at all. We're really going to be focused on some of the in and outs of handling polish inside of an Electron application, especially when we're working with drop-down menus and multiple windows. Let's get started on this application by generating a new NPM project and installing Electron. I'm going to start by flipping over to my code editor. I'm going to make sure that I change out of the working directory that we were in before. So notice that I'm no longer inside of the video info directory. I'm outside of it, and I'm going to create a sibling directory to it. So this is going to be our new project. I'm just going to call it to-dos, and I'll change into that directory. Now once I'm inside, we'll get started by generating a new package.json file. So we'll run npm init. Again, we don't really care about the inputs in here too much, so we'll just go right on through it. Very good. Now that we've got a package.json file, we can install Electron as a dependency by running npm install -- save Electron. Now this is going to take just a second to install, so let's take a quick break, and when we come back, we'll continue with our application. Our user now has the ability to submit a to-do, but it'd be really nice if we made sure that whenever a user clicks add right here, we just automatically went ahead and closed the entire window. Because really, clicking add means I'm done with this thing, just make it appear on the list. I don't have to click add and then click X right here. That's just a pain in the rear. To make sure that we can close the window automatically, we can just add another line of code to our to-do add event handler right here inside of our index.js file. To programmatically close that add window, well, it's pretty straightforward. All we got to do is call add window.close, like so. Let's test this now. I'll do my npm run electron again for the 1,000,000th time. I'll open up my new to-do, put my text in, click add, and ta-da, window goes away. So, okay, yeah, that seems pretty straightforward, but I want to mention something here because I just opened a huge can of worms that starts to bump into one of the biggest performance concerns in the world around Electron. To understand why what we just did right here is really poor practice, I want to first start by talking to you, telling you a little bit about how the garbage collector in JavaScript works. So when I say the word garbage collector, I'm referring to JavaScript's ability to first declare an object, and then after we don't use it anymore, after we decide that we don't need that object anymore, allowing JavaScript to come back and claim the memory or the RAM space that was used to create that object. So remember, whenever we create an object of any type inside of JavaScript, that's operating, or that's committing, it's using up some amount of memory. If we don't clean up after ourselves after some amount of time, our application will start to hog more and more memory until eventually our program says, hey, not enough memory, we need to close out. This is a very common problem in the world of Electron, but fortunately there is a very easy and a very straightforward solution. Let's first start by making sure that the garbage collection process is really clear so we understand what's going on with it. Okay, so ignore the bottom half of this diagram right now. I want to focus on just the top half. Let's say that we have some amount of code that says, okay, declare a new variable called add window, and then assign it a brand new browser window. We'll assume that some amount of time passes, and then eventually we say, hey, you know what? This old browser window is really lame. I don't like it anymore. I don't want to deal with that old browser window. We're going to make a brand new browser window and assign that to the variable add window instead. If the only code that we had running inside of our application was the stuff we see on the screen right now, so we can assume that no other variable is pointing at the browser window that we made, when we redefine the object or the variable that add window is pointing at, so when we say, hey, add window should now refer to this new version of browser window, no variable inside of our application is pointing at the old one anymore. In JavaScript, when no variables point at a particular object, JavaScript assumes, well, the user or the developer is not trying to access this object anymore. They don't have any variables or references to it. Chances are they don't need it, so I'm going to come through and clean it up. I'm just going to take care of it and throw it out the window. I'm going to reclaim that memory. So this is what we want to make sure happens as much as possible inside of our application. But the way that we wrote our code right now kind of breaks this convention. And not egregiously, it's not the worst thing in the world the way we've put our code together, but I just want to make sure it's clear where I'm coming from here. So let's take a look at what we're doing. Okay, so here's addWindow.close. The important thing to understand about addWindow.close is that when we call close on a browser window, that essentially means kill this window, just dump it entirely. Say, hey, it's done, remove it from the screen, we're not going to show it to the user again. That's it, I'm totally done with it. Now the problem there is that we still have a address in memory, we still have a reference to add window, and that is the variable add window right here. So really it's the exact situation that I showed in the diagram right here. Add window is pointing at this instance of browser window. And when we call close on this thing, we clearly are saying, I don't want to use you anymore. You're totally done. Get out of here. Your history, you're toast. But that does not reclaim that memory in space or reclaim the actual RAM that that object was occupying. To make sure that we actually reclaim that memory, to make sure that we actually clean up after ourselves, we need to look back at the add window variable right here and just make it point at some other value. Just by saying, hey, add window, don't look at the browser window anymore. Don't look at this thing. Just look at something else. Point at some other value. Just by doing that, we allow JavaScript to automatically go back and garbage collect the browser window instance that we had been using. So in practice, in Electron code, after we close a browser window, we will always take the variable that was referencing that browser window and point it to null instead. By making that value or variable point to null instead, we are no longer maintaining a reference to the browser window, and that allows JavaScript to clean up after ourselves and essentially reclaim all that memory that was being made use of. So in practice, how do we actually do this? How do we say, hey, add window? Don't look at the window anymore. Don't look at the browser window. Look at null instead. Well, there's two ways we can do this. We could either put a reference or we could put a line directly underneath and say add window is null. The other much more reusable, much more easy, straightforward solution of doing this is to attach an event handler to the add window object itself. So we'll say up here inside of create add window, we'll say add window dot on closed. So whenever that window gets closed, like as we're doing literally right here, right underneath it, then run this arrow function in which we'll say add window is null. So when we close out the browser window, this arrow function is executed. We say don't look at the browser window anymore, pretend it doesn't exist, allow it to get garbage collected, and we do that by setting the reference of add window over to null. And that's pretty much it. Now, one thing that you might be a little bit curious about is, hey, how we're doing things right here, is it the worst thing in the world? Well, no, we're not really doing, if we had left this line out right here, it really wouldn't be the worst thing in the world for us, like personally with the application we're working on right now. Because remember, every single time we go up to File, New To Do, we keep on rerunning this create add window function, which keeps reassigning the add window variable again and again and again. So every single time we open up the add window, or we run this function, we assign a new instance of the browser window to add window, which puts us back into like, really, come on, there we go. Which puts us into this type of situation right here. So the instant that we open up a new to-do window, add window gets reassigned to the new version of it, and we are dumping off the old version. So again, it's really not the worst thing what we're doing right now, but I really just wanted to take this as a very easy, very simple location to point this out and explain this whole process of garbage collection. In larger applications where you might open up multiple instances of a second window, or the entire process of redefining this add window variable right here might not be quite as clear, that's when you want to be really aware of how you're handling this garbage collection and cleanup. Okay, so this has been quite a little discussion about garbage collection, but I think that the code that we have now really takes care of it. Let's continue in the next section and make sure that the main window that we have put together will receive this to-do add event and then append the to-do to its actual HTML document. So let's tackle that in the next section. The quit button inside of our file dropdown is now working the way we'd expect, but there's still one aspect to it that is not quite working the way that we would hope. I'm on OS X right now, and when I press Command Q, absolutely nothing happens inside my application. If my app was working like a traditional OS X application, however, I would really expect that pressing Command Q would close out or quit the application entirely. Likewise, if I was on Windows, I would expect doing maybe Control Q to close out of the application. So it's clear that this quit button right here isn't quite working the way we'd expect. Like, it'd be really nice if we could somehow associate a key combination with this particular menu option. Fortunately, that option is available inside of Electron. To associate a key combination or a hotkey with a particular menu option, we can add on an accelerator property. The accelerator property takes a string representing the key combination that we want to work for, or watch for, I should say. So whenever I press some particular key combination, which we refer to as the accelerator, it will invoke the click method associated with this menu option. We're going to set up the accelerator to work with OS X for right now, and I'm going to get the thing working, and then we're going to come back very quickly and make sure that it works with Windows correctly as well. So first we'll take care of OS X, and then we'll do Windows. For the accelerator, I want to watch for the key combination of Command plus Q. This is how we write out key combinations with Electron. We simply say the modifier key, then the key that we want to watch for after the modifier, and we can join the two together with a plus. If we want to, we can chain together a bunch of different modifier keys as well. So we could say, for example, Alt plus Command plus Q, or Control plus Command plus Q, or Command plus Alt plus Q. Really, the options are endless here. You can set up any type of command key that you want. So with just the Command Q setup right now, let's try our application again. Again, I really only expect this to work on OS X for right now because Windows doesn't really have the concept of a command key. Again, we'll take care of Windows in just a second. I'm going to restart my application now. And when I do so, I'll now look up at File, and you'll see that Electron has automatically associated that Command Q shortcut with the quit option. So now when I press Command Q, the entire application exits, just as we would expect. Okay, so that definitely takes care of this solution, but only on OS X. So now let's look at this again, but figure out how to make sure that it'll work on both platforms, both OS X and on Windows. Really what we want to do right here is change the accelerator that we're looking for based on the current platform. To do so, Electron allows us to not only pass in or assign a string to this accelerator property, but it also allows us to assign an immediately invoked function. So here's what we're going to do. We're going to define the function. We're going to wrap it with a set of parentheses. And then after that set of parentheses, we'll add another set. This is referred to as an immediately invoked function, or a function that is invoked the instant that is transpiled by the JavaScript interpreter. Inside of here, we can place some amount of logic that returns the correct key combination to use depending on our current platform. Remember that we can check to see what the current operating system is by looking at that process.platform key. So inside the accelerator, we'll say if process.platform is Darwin, then go ahead and return command plus Q. Otherwise, we're going to assume that we must be on Windows, and instead we'll return control plus Q. So this will suit the case for being on Windows, and this will suit the case for being on OS X. So let's test this out and see how we're doing. Obviously, I'm not recording on a Windows PC, so I can't quite test to make sure that it works correctly on Windows, but I can certainly at least make sure that I can still quit correctly out of OS X. And it looks like I can just fine. Very good. Now, last thing I want to say about this right here is that we could also condense this logic a little bit. We certainly don't have to have the full immediately invoked function here. We could instead use a little ternary expression, which will dramatically simplify the amount of logic that we have. So rather than this big long block, I'm going to take it all out, and I will replace it with process.platform equals Darwin, and we're going to define a ternary expression. So I'm going to place a question mark and then a colon. Now, if this statement right here returns a truthy value, so if we are currently on Darwin, this entire ternary expression will return whatever we place between the question mark and the colon. Otherwise, it will return whatever is placed after the colon. So in practice, we can do something like command plus Q. So that's going to handle the case in which we are on the Darwin platform. And we can also handle the case in which we're not on the Darwin platform, which would be control plus Q, like so. You'll find that the official documentation does that long form immediately invoked function. And so to be honest, I really just want to show you both different options to give you a sense of, hey, if you want to, you could use the big long function, but honestly, I really recommend just going with the ternary because it's a lot more compact right here. Okay, let's test this out one more time. So I'll open up the application. I'll check the file button. Yep, still have command Q there. Now when I press it, the application still quits. Okay, so this is looking pretty good. We've now set up a submenu option. We've assigned it 2 separate buttons. We've set up a click event handler on one of the buttons, and we've set up a hotkey accelerator on that same button as well. Let's now continue by focusing back on the new to-do button and make sure that when a user clicks this, we show an additional window to the user that they can use to create this brand new to-do. So let's tackle that in the next section. Now that we're sending an event over to our main window, we can flip on over to our main.html file and add a little bit of code to receive this to-do add event. When we receive that event, we'll then append a new element to our list of to-dos that's going to contain the text from this to-do right here. Now, one reminder, when we flip over to the main.html file, we're using mainwindow.webcontents.send to get the event over there. To receive the event on that side, we'll make use of that ipcrenderer.on. Okay, so back inside of our main.html, We have essentially nothing right now to show. We'll put in a little script tag that's going to contain all of the JavaScript that we're going to add. Now we know that we're going to need to make use of the IPC renderer, so let's just start off immediately by getting a reference to Electron. Oops, require Electron. And then we'll destructure off IPC renderer from Electron. Now we can listen to the IPC renderer and say .on, and we want to watch for the event of to-do :add. So we'll say to-do add. When we see this event, we're going to execute this function, which has 2 arguments. Remember that the first argument is the event object, which describes which process this thing is coming from. And then the second, which is the actual to-do. Then inside of here, we'll add a little bit of code to append the to-do that we just added to a list of to-dos. Now, since we're building up a list, I think that it would probably make a little bit of sense to put down a UL element right underneath the H1 that we have that will contain the list of to-dos. So we'll put down an empty UL. Then inside of here, we'll use a little bit of fancy JavaScript to create a brand new li tag, put the text inside of the li tag, and then append that to the UL. So again, what we're about to do is not at all related to JavaScript, or excuse me, it is related to JavaScript. It's not at all related to Electron. This is just a little bit of very vanilla JavaScript code that we're going to write for manipulating the DOM. So we'll say, we'll make an li element by doing document.create element. So I'll make myself a new li. I'll then make myself a new text node. So create text node that's going to contain the text from the to-do. Then I'll take the li and append the text node to it, and then I'll add in a selector to get access to the UL, and then append the li to that. So we'll say document.query selector, look for the UL, and append on the li. Okay, so I think that looks pretty good right there. I think we're about ready for a test. I'm going to flip over to the terminal, start up Electron. I'll go to File, I'll add a new to-do, and I'll say take out garbage. I'll add it, and there we go. Take out the garbage, append it to my list of to-dos. So this really hasn't been too bad. We've gotten a good overview of additional IPC render practice. We got a good overview of how the menu works up here. And we also spoke a little bit about how garbage collection with Electron works. Now, before we move forward, there's one last thing I want to take care of inside of the menu up here. Inside the view tag, right now we have the ability to toggle developer tools, but there's one other really critical process or critical task for doing effective debugging of our code. So I would really like to also have the ability to refresh the HTML document inside this window, so that if we change anything inside the HTML document, we don't have to restart the entire application over here. Remember that whenever we change the content of the actual browser window, we don't have to restart the entire Electron application, we just have to refresh the browser window itself. But again, remember that when we redefined the menu up here, we lost out on that ability to reload because we just blew away all the different event handlers and all the different quick binds that were already set up, or key binds. To take care of the ability to refresh our application or refresh the code inside of here, we're going to add on another submenu item inside of our index.js file. So I'm going to change on over to index.js, and then I'm going to scroll on down to the bottom where we set up some of our submenu options for handling the debug process. Inside of here, we're going to set up another option and another thing for the user to click on. Now you might be thinking, all right, Steven, yeah, I get it. We're going to do a label. We're going to do our accelerator. We're going to do our click, blah, blah, blah. We get it. Well, not this time. Haha, I'm tricking you. We're going to do things a little bit differently this time. You see, when we make use of Electron, of course they know that as soon as we start messing around with the menu template, we're going to blow away all of these options. And so Electron by default has recognized that, yeah, we want to make it really easy for you to wire back up these very common debug tasks that you might have. So rather than defining the label, the accelerator, and the click this time around, we're going to take a little shortcut by specifying a roll and then giving it the value of reload. So behind the scenes, Electron has a number of preset roll options available, one of which is reload. When Electron sees this option of roll with reload, it's going to say, oh, they probably want to have a label of like reload my code. They probably want to set up that quick bind of Command R, and they probably want to make sure that the contents of the window get reloaded as well. So really, we can think of roll right here as just being a shortcut for being able to reload our code. Now this time around, we did of course change some code on the Electron side of things. So we have to restart the running Electron process. But when we do so, we can now check our view option and we have the full reload option available to us. Looks like the Command R is already set up on there. Let's give it a little shot by adding in a to-do, and then I should be able to hit Command R and refresh the entire page. Awesome. So again, there's a handful of different roles already available to us. You can check out the documentation to learn a little bit more around them. Okay, so that's pretty much it for this application. However, I feel like I've been doing a lot of talking and telling you how Electron works. I think that maybe this would be a good time for you to work on your own little feature to add to this application. So let's take a quick break and then come back in the next section and talk about a little addition that I would like you to make yourself to this application. So I'll catch you in the next section. I think that we're about ready to start enhancing the functionality around the form in our add.html document. So we want to listen to the input in here, or listen to the form itself, I should say, and then once the form is submitted, we'll take the value out of this input and somehow get it to appear on the main window screen. Whenever we talk about communicating from one window to another window inside of an Electron application, we always want to be thinking about the IPC system. Remember, inter-process communication. So here's a thought. Here's what we'll probably end up doing. Inside of our add window, we'll listen for the form submittal event. Once the form is submitted, we'll take the text out of that input and then emit an event to the Electron app, which is our index.js file. And we'll say, hey, here's a new to-do, add this onto list or whatever you want to do with it. Then the Electron app will then trigger its own event and send an event on over to the main window, which will then receive the new to-do and append it onto its list of items that need to be completed. So essentially, 2 jumps to get information over to this other window inside of our application. Let's start working on the form submittal event inside of the add window and then start figuring out how we'll address these IPC issues. So I'm going to go back to my code editor. I'm going to find our form tag, and right underneath it, I'll add a script tag where we will add a little bit of JavaScript to watch for the submittal event of the form. So we'll use document.querySelector to get the form, and then we will add an event listener, watch the spelling on that one right there, to watch for the submit event. Then whenever the user submits the form, we'll add in this arrow function. I'm going to shrink the size for just a second so you can see everything here. And then we'll receive the event, because remember, whenever a form gets submitted, the form will try to submit itself, and we want to prevent that default behavior. So on the event object itself, we'll call prevent default. Okay, so then inside of here, this is a location where we're going to want to pull the value out of the input and then use the IPC system to message the new to-do over to our main window. I think that for right now, maybe a good next step would be to place a debugger statement. And maybe we will enter into the debugger. Remember, that's going to pause execution of our code. And then we can write a little bit of another query selector in the console on the fly to figure out how we're going to pull the value out of the input right here. So really, I just want to do this very carefully, one step at a time, so we can figure out how to get our value out of the form. And of course, maybe there's another little issue or another little gotcha we might run into along the way. So let's just see what happens. So I'm going to start up Electron. Here we go. Here's our application. We will add a new to-do. Okay, and let's enter in our to-do. And now when we hit the add button, which will submit the form, I'm going to expect our event handler to take over, and I'm going to expect to see execution of our JavaScript code pause on this debugger statement right here. Okay, so let's see what happens. I'll click add, and nothing happens. Huh. Well, that's interesting. Okay, well, you know what? Okay, I just remembered. Whenever we have a debugger statement, we have to have our JavaScript console open inside the browser. That's the only way in which the debugger statement will catch. So, okay, let's figure out how to open up the JavaScript console inside of this window right here. I'll go up to the menu bar and, oh yeah, we wiped out the menu bar. When we wiped out the menu bar, we lost the ability to open up our developer console. And even if I remember my keybind for opening the developer console, which is Command-Option-I, I can smash that all day and the developer console won't open. So when we blew away the default menu set, we also lost the ability to open up our developer console inside of the development environment, which is definitely not very useful considering we still want to do some amount of debugging of our code. We can't use debugger statements, we can't use console logs. We're definitely very handicapped on the front of doing any type of debugging over our code base right now. So I think that we should probably do a quick pause here on handling the form submittal stuff and figure out exactly how we're going to get access to the developer console inside of our application again. So let's take a pause here and let's flip on over to our index.js file and figure out how we can somehow get access to our development console again. Now remember, when we previously used the developer console, we were opening it through the use of a view menu up here. Now, there's a little bit of a consideration here. Obviously, we don't really want our users to have the ability to open up the developer tools at all. Like, we really don't want them to see it at all. So I think that what we should do is add in a check to see if our application is being ran or executed in a development or a production type environment. And depending on that check, we'll then either choose to show the button up here to show the developer tools, or we won't. We won't allow the user to open them up. So here's what we're going to do. Down at the bottom of the file, underneath the existing platform check that we have, we're going to add on another check inside of which we will start to modify the menu template that we have. So the check that we're going to make in here is to look at the environment variable node_env. This is short for node environment. On most JavaScript projects that you ever work on, the node_env environment variable will be one of three values. It will be production, development, or staging. And sometimes you'll also see pretty frequently test as well. These are not hard-coded or really strictly enforced environment variables. Rather, they are by convention what we use to determine what environment our application is currently running in. And so for us right now, we can just assume that maybe we should be running in the development environment. So I only want to show my debugger or my console tools or my developer tools if we are not inside the production environment. So we'll say, okay, if we are not running in the production environment, then I want to add in the ability to open up those developer tools. To do so, we're going to create another entry inside of our menu template array. And inside of there, we'll put a menu where we can open up our developer tools manually. So we'll look at our menu template, and we're going to push on an additional entry to the end of that array. So when we say menu template.push, remember that's going to give us another clickable submenu up here. Right now our application only has file. So here's file right here. When we push on that additional object, we're going to see an additional entry over here. So I think that maybe we'll call this thing about view. That's what it is by default inside of Electron. I think that another very reasonable label would be something like developer or debug. And the reason I think that these would be a little bit more appropriate would be that if you get your production deployment of your application together and you run it just to test it, make sure everything's working okay, I think seeing the text up there of like developer would be a way larger red flag to you to say like, oh, hold up, I made a big mistake and I'm showing a menu that I'm really not supposed to. So even in that regard, maybe you want to do like capital D developer, just to make sure it's really clear, hey, you should only see this if we are not in the production environment. But again, just to stick with the convention of Electron, maybe we'll keep things simple and stick with view. But again, it's totally up to you. You can go any route you want. Okay, so we're going to set up a submenu here. Remember that this submenu is going to be an array that contains a list of different objects. The submenu lists out all the different entries inside of this menu. And each object in there represents one specific entry. So we want to add in an object that's going to toggle developer tools. That's the goal here. Okay, so whenever a user clicks this, so we'll set up our click event handler, we get access to 2 arguments in here. And you'll notice that in the past, I didn't mention any arguments for the previous click handler we put together. So here's the click for the new to-do. So I didn't really mention anything about this one previously. But in this case, it actually is kind of relevant. We kind of want to know a little bit about these arguments. And let me tell you why. When we open up our application, there's 2 separate browser windows, 100% independent, right? Well, more or less pretty darn independent. They belong to the same application, but really they're showing different HTML documents. And so we can really think of these things as being pretty darn separate. When we go up into the menu and click this new View button that we're going to see in just a second, and then click Show Developer Tools, we want to figure out which of these windows we show the developer tools in. For example, if I have this window right here selected and I hit Show Developer Tools, I want to see the developer tools appear in this window, not this one over here. So to make sure that we open up the developer tools inside of the correct window, we're going to receive one of the arguments to this click handle right here. So the first argument is something that we call item. In this case, we don't really care about item, but we do care about the second argument, which is focused window. Focused window is a reference to the window that is currently selected or highlighted by us, the developer. So if I click over to this window, it's now focused. And if I went to View and then Show Developer Tools, that focused window object right here would be a reference to this window. So then we could then somehow figure out exactly how we're going to toggle on the developer tools inside of this specific window. So doing so is pretty darn straightforward. We can say focused window dot toggle dev tools, like so. Okay, so that's a lot of explanation for one, I guess it's a pretty sizable block of code. I think that we should give this a test and see how we're doing. So I'm going to flip on over to the terminal. I'll restart the application. And now just to do a little test, I won't worry about the add new to-do window just yet. So I've got this one window open. Here's my new view box. I'll hit toggle developer tools. And fantastic. We get our tools opening up that we can then use to look at the inside HTML document or do any debugging that we might want to do. Okay, so this looks like some pretty good progress that we've made. We've got our developer tools back. I think that the last thing that would be really nice, I don't know about you, but me, I love to use the hotkey to open up these developer tools. So I think it'd be really nice if we added a hotkey for opening up the developer tools here. Remember that we add in hotkeys by defining that accelerator property. I'm going to use another ternary expression because we want to make sure that the hotkey for opening the developer tools, it's going to be slightly different depending on your platform, whether or not you're on OS X or on Windows. So we'll look at process.platform again. We'll ask if we are running on Darwin, or in this case, OS X. And then if we are, I want to use the hotkey, let's see, Command Alt I, so Command plus Alt plus I. Otherwise, if you're on Windows, I believe the default hotkey is Control Shift I, like so. So this would be our Mac OS hotkey, and this would be our Windows hotkey over here. So now, whenever we are trying to develop or test our application on either platform, the proper hotkey is going to take over for us. Okay, so let's do a test of this now. We'll kill the console, open everything back up, and it looks like I got a little typo in here. I probably forgot a semicolon or something. Yeah, I didn't forget a semicolon. I added one in when I shouldn't have. It needs to be a comma. Second time I made that mistake, I apologize. Now let's try this again. So we'll boot everything up, and now I should be able to hit Command-Alt-I or Command-Option-I, depending on how you want to refer to it. And yep, everything looks good. We got our developer console open. Now I should be able to go over to my new to-do window and open up the developer tools over here as well. Okay, so after a pretty good amount of work, we can now continue in the next section where we will resume with handling the form submittal for our new to-do to make sure that we catch on this debugger statement. So let's take care of that in the next section. In the last section, we got an additional form to appear on the screen, but we ran into a little bit of snag when we realized that if we close out the window behind that Add To Do window, we don't really have the ability to open that window back up in any way, shape, or form. Now, I think that a real reasonable solution would be to just close the entire application if the user ever closes that main window behind it. So if I click that X up there, I should see entire application just stop. We're going to assume that means the user doesn't want to use this thing anymore. Handling this is going to be a little bit easier than you might think. I'm going to find our app.onReady event handler. Here it is right here. We can attach an event handler to the main window right here and watch for when the window gets closed. So whenever the user clicks that X to close the window, we can then forcibly quit from the entire application. So right underneath the main window.loadURL call, we'll add on another event handler. We'll say main window.onClosed. So whenever that event occurs, we'll call app.quit. We've already looked at app.quit once before. Remember that app is the overall running Electron process. If we call .quit, that's going to kill the running process and the entire application is going to close. We also made use of another built-in method or another built-in event handler inside of the Electron world right here. So this is an event name that is published automatically or handled automatically by Electron for us. Whenever a browser window is closed by the user, it emits this closed event right here. So we can set up an on listener and wait for that event to be emitted. Then whenever the user closes the window, bingo, we're going to close the whole application. So let's try this out. I'll save that file. I'll restart the Electron process. And now, if I open up the new to-do window and then close that big window behind it, everything closes all together. And so I think that works much more realistically. I think that really sticks to how I would expect the application to behave. So once I'm back here now again, I can close this out and yep, everything's gone. So it's not just tied to having that smaller window open, right? It's not just the case in which we have add new to do open right here. It's also the case in which this is the only window open and we press the X right here. In either case, the main window will emit that closed event and we can forcibly quit from the entire application. Now I want to take just a real quick moment and mention to you that I know that handling little details like this probably seems like an awfully boring thing to worry about inside of the Electron world, right? Like, I don't know about you, but thinking about the state that my application can be caught in based on my user clicking around and opening, closing windows seems like kind of a trivial thing and something that, I don't know, I don't have tremendous personal interest in. But at the same time, handling small details like this right here is absolutely, unequivocally what is going to turn your Electron application from feeling like a second-rate app into feeling like a first-class desktop experience. So as we go through Electron applications, we really want to be thinking about the small details like this. We want to be remembering that a user can get easily into these funky states, and then we need to handle them gracefully. On the desktop, on the web, we really don't have to worry about these kinds of conditions that much, right? Because at the end of the day, a user can always hit the back button or refresh the browser and be a-okay. But when our desktop apps start to break, a user really might not know that they can, or they should, let's put it that way, can or should, know that they should be quitting the entire app and then reopening it just to get back to this main window. We want to make interactions like that as clear and obvious as possible when we are on desktop. So again, although this might seem like a kind of boring detail to have to think about, it really is what distinguishes a professional desktop app from an amateur or a beginner one. So it's something that we really do want to focus on as much as possible. Okay, so that's my little spiel about adding polish to Electron applications. I think that we've got a good solution for handling the closure of the main window. So let's take a quick break and then we'll come back and continue working on the functionality around the add window. So I'll see you in just a second. Okay, hopefully you had some luck with adding this additional feature into our application. So hopefully you were able to add a button into the menu up here, and then whenever a user clicked it, you were able to communicate something down to the main window and clear out the list of all of our to-dos. So let's walk through the solution together. When I'm looking at this, I'm definitely seeing an additional option or an additional thing to click inside of our file menu dropdown. So to me, my mind is immediately thinking towards our menu template. So here's our existing menu template inside of the index.js file. I really want this option to always be visible to the user. I don't want to gate it around some platform check or some production environment check or anything like that. I just always want the user or developer to be able to clear the list of to-dos. So I think that adding an additional option to my base menu template right here is probably the way to go. I'd like to show the extra button to click, or that extra option to click, between the existing new to-do and quit options. So between the two of them, I'm going to define a new object. I'm going to make sure to get my comma in there too. And then I'm going to give this thing a label of, how about clear to-do list, or whatever you came up with is totally fine. I think I said clear to-dos. So maybe we'll stick to the diagram. We'll say clear to-dos. Now, whenever a user clicks on this, we want to execute some amount of code. So we'll add in the click handler to this object. We'll say click. And whenever a user clicks on the thing, we run this function. We want to communicate this event down to the main window. Remember that we communicate from the Electron app down to the main window by using that main window.webcontents.send. So we'll say main window.webcontents.send. And then to stick with our existing type of nomenclature where we say to do and then the thing we want to do, we'll say, how about to do clear, like so. I think that's appropriate event name. So that's pretty much it on the menu template side of this task. We're now sending down the event successfully to the main window, which means we can change over to our main.html file and add an additional event handler inside the script tag over here. So remember that whenever we are inside of our main window, or really any browser window, we receive events from the main process by watching ipc.render.on. So underneath the existing event handler, we'll add another call to ipc.render.on. We'll say to do clear, because that is the event that we just issued from our index.js file. Here it is right here. And then as a second argument, we'll add in a arrow function that will be executed whenever this event comes across. Now in this case, we aren't really sending any arguments along with this event. So we're not saying like, hey, here's the to-do to clear, and we don't really care about who issued the event. So I don't think that we need to add any arguments into this list right here. All we really have to do is clear out the big UL, or the big list of all of our elements. And remember, to do so, we can use that little code snippet that I showed you, where we'll take a reference to the UL and then set its inner HTML property to be an empty string. So I'll use my document.querySelector to get the UL. Then we'll say its inner HTML, and make sure you capitalize HT and ML. Wait, HTM and L, there we go. and we'll set that to be equal to an empty string. Okay, I think that we are ready for a test. So of course, we'll go through restarting the Electron process. I will add a couple to-dos here. So there's 1, 2, 3. And then we will click on the Clear To-Dos item right here. And it clears out the whole list of to-dos. Awesome. Now one refactor that I might do here, just to point out really quick, because this does bug me. This is the kind of thing that keeps me up at night for whatever reason. We've got query selector for the UL in here twice in very quick succession. And nothing about the UL itself is really changing. We're just changing its children. So rather than selecting the UL twice, I think that we could probably dry up our code just a little bit by getting a reference to the UL ahead of time. So we'll say that the list is document.querySelector. And there's the UL. And then we can clean up the code down here by just referencing list. Like so. Okay, so that's looking pretty good. Hopefully you added in that feature. Hopefully it wasn't too bad. If you had any difficulty with it, hey, don't sweat it. Of course, we're going to get a lot more practice with IPC as we go throughout this course. I hope you enjoyed putting this application together. We spoke a whole lot about how to deal with menu templates. We spoke about how to modify menu templates depending on the platform or the development environment that we're in. We spoke about how to deal with submenus and take shortcuts for implementing very common items inside those submenus. And then we also got a lot more practice with the IPC. And perhaps most importantly, we had a pretty good discussion about how to handle garbage collection with Electron. Definitely something that you really want to keep an eye on whenever you're working on a production application. So I hope you enjoyed putting this application together. I know that to-do apps are always boring, but again, we didn't really care about the to-do side of things. We really cared about just focusing on the Electron side. So let's continue in the next section, kick off our next application, and let's figure out how to learn a little bit more about Electron. Now that we've got our project boilerplate out of the way, we can start thinking about some of the particular challenges of this application and then start tackling them right away. We're going to run into some gotchas pretty quickly, so I'm pretty excited to run into those and figure out some more of the details behind Electron. To get started, let's flip back over to our mockup and take a quick look at the first element that I think we should be building, which is the menu at the top. So again, remember that on Mac OS versus Windows, this menu is going to appear slightly differently. On Mac OS, we'll see this menu pop up on the very top status bar, like this right here. But if you're on Windows, you'll see it appear more as it does in the diagram right here, where it'll be a part of the actual menu window. We can refer to this entire drop-down thing right here, remember like essentially this up here, as being a menu. The terminology around this menu is actually rather important, so let's take a look at a diagram that's going to label a couple of different pieces of anatomy around this menu. Okay, so first off, you'll see in this file dropdown right here, this file menu, a couple of different pieces of text. No matter where the text is inside this menu, we always refer to it as being a label. So across the board, it's always referred to as a label. Clicking on the menu itself will open up the submenu. So the part that drops down or the part that opens up down here is referred to collectively as being the submenu. To put this into very obvious use, this entire section that pops up right here, like this entire rectangle, we would refer to as being the submenu. And then the text on here, like new project and open project, is referred to as being the labels. Let's change over to our code editor, and we're going to walk through the process of creating our own menu and submenu. Back inside of our index.js file, we're going to start off by importing a module off of, or I should say destructuring a module off of the Electron object. This is called the menu object. So we just destructured off the menu property. This menu object right here is used to create custom menus that you can place inside of your own Electron applications. Making use of this menu object right here is pretty straightforward, but it's one of those things where you kind of got to walk through it one time nice and slow before you kind of get a sense of what's really going on. So for this first menu that we're going to put together to show the new to-do and the quit buttons, we're going to do it nice and slow, but then after that, we'll be able to speed up just a little bit. Whenever we want to create a menu, the first thing that we do is to create a menu template. A menu template is an object or an array that kind of is structured like how we want our menu to be put together. For this first menu template that we're going to put together down here, we'll go through it and not talk too much about the code. Well, maybe we'll talk a little bit about it. But after we go through it one time, we'll then do a big review and talk about some of the similarities between the menu template we put together and how it actually appears on the screen. So underneath the app.onReady call, I'm going to declare a new variable called menu template. Now menu template is going to be set equal to an array, and this array is going to contain exactly one object. We're going to pass in a single object here because the menu that we are trying to build only contains, or excuse me, the entire menu strip up here, I should say, the entire menu bar contains only one drop-down menu. Each object that we add to this menu template corresponds to a single drop-down on the status bar at the top. So if we were building a menu template for the code editor Atom, we might have about 6 or 7 different objects inside of this array right here, each object representing file, edit, view, and so on. Every object that we place inside this array is going to have at least one property assigned to it, and that is the label property. The label property is used to label the actual menu that we're clicking on. So if I wanted to build this menu right here for Atom, I would assign it a label of file, and that would give this first dropdown right here the name of file. Without putting any additional configuration in here, let's set up our menu template to be used by our application and then run this from the command line and just see what happens when we only specify a single option with a single menu. To get this menu template in use by our application, we're going to make further use of the menu module that we just imported. So when the app is ready, after we create our main window, we can then use that menu object right here and the menu template to actually create the menu that will be used for the application. I'm going to call this thing main menu. The first thing we're going to do is take the menu object, which we imported right here, and we're going to call a helper function on it called build from template. And then we're going to pass in the menu template that we just created. So now main menu, you can imagine, is some hopefully intelligent object that describes exactly how we want our menus to appear inside of our application. Just creating or just calling build from template doesn't actually create the menu, however. We have to actually call a second function to actually make sure that it gets put in use inside of our application. To do so, we're going to then call menu.setApplicationMenu, and then we'll pass in the main menu that we just created. Now you might be curious, why in the world did they separate this into 2 separate function calls? Why do we have to first call build from template and then call set application menu? Well, I don't know exactly why we have to call build from template right here, but I can tell you that there's a very good reason to maybe build the template ahead of time if you really think about it. Imagine that we're building an application where the menu at the top changes depending on what window we're looking at inside the app. So maybe if we have several different windows inside of our application, we want the menu bar at the top to change over time. And so it's entirely plausible that we might be calling set application menu several times throughout our application lifecycle. That's not going to be the case in this application we're putting together right now, but you could definitely imagine that depending upon the state of the application, maybe we really want to show different content up here. Okay, so now that we've created our menu template, we've built our menu from the template, and then we've set that as our application menu, I think that we're at a good point to test this out using Electron and just see what we have working right now. So I'm going to flip over to my code editor, or excuse me, my terminal, my mistake, and then I'll start up my project by running npm run Electron. Now when our application boots up, we can look up at the status bar and you'll notice, this is kind of interesting. It looks like we have the button Electron, but nothing else is visible whatsoever. So it looks like there's probably a little bit of a problem here, and I can tell you right now that this is going to be one of the first gotchas that we're going to run across in the world of putting together these menus. So let's take a quick break and then we'll come back and figure out exactly what's happening here. So I'll see you in just a second. In the last section, we put together our menu template and set it up as the application menu. The instant we opened up our application, however, we noticed that all of the existing bars or all the existing buttons up on the status menu completely disappeared. And so this is a little bit of a gotcha with Electron. As soon as you decide that you want to take over the responsibility for rendering the application menu, your menu template will completely displace all of the default buttons that are there. Just to prove it to you, I'm going to comment out that segment of code right there. So we're no longer setting the application menu. And then I'm going to restart my Electron process. Now when I do so, we're back to seeing the Edit, View, Window, and Help buttons up here. Now you might be thinking, well, Steven, that's totally okay for me. I am totally happy if we go through life using my template up here. Totally fine. Well, I don't know. Maybe it's not quite as straightforward as you might think. Again, this is quite a little bit of a gotcha. So let's talk about what the shortcoming here is. Remember that when we were talking about reloading the application, so just reloading the content in the window, or when we were talking about the hotkey for toggling the developer tools here. So in both cases, I would hit Command R to refresh the document, or I could hit Command Option I if I'm on Mac OS to open up the developer console over here. In addition, we could also do things like, say, minimize the window by hitting Command M, like so. Okay, so we have all that built-in functionality, and gee, it sure looks pretty nice right now, right? Like it's working the way we expect. Now I'm going to uncomment all this code right here. So we are now displacing the existing application menu. Now I'm going to restart the application again. The application pops back up. Yep, menu's gone again. And now here's the big surprise. I'm going to hit Command R. Nothing happens. I'm going to hit Command Option I. Nothing happens. I'm going to hit Command M. And nothing happens. So when you set the application menu and you replace the default Electron one with your own menu, like your own code, you're not only replacing the entire menu up here, but you are also breaking all the default keybinds that are associated with Electron as well. So when you want to put your own menu here up at the top, you're really signing up for a pretty good chunk of work. You're saying that not only are you going to add on your own custom menus and your own custom buttons, but you're also going to set up all the keybinds here as well. Now, in a production environment, this isn't the biggest deal because in the production world, you probably don't want your user to have a hotkey to open up the development menu over here, right? And you don't really want them to have the ability to hit Command R to refresh the page as well. So maybe it's not the worst thing, but certainly if we're talking about very common application management techniques like that Command M to minimize the window or Command Q to quit out the application entirely. Like I'm hitting Command Q right now and nothing's happening. So although we do kind of drop some functionality that we wouldn't want in a production environment anyways, we do need to be aware that we also lose some functionality that we would probably want to maintain as well. So how does this all relate to our application? For our application, we're still going to continue moving forward and putting together this file menu right here. And we're going to put in the quit button and the button to add a new to-do. And then we're also going to investigate how we can add back in some features like having the ability to reload the page or to toggle open the developer console on the right-hand side as well. So we will investigate how we can restore some of that functionality too. For right now, I would like to continue working on our first menu over here. So the menu that's going to show the file dropdown along with the ability to add a new to-do and to actually quit the application. So let's focus on that for right now. The first thing we'll work on is showing a button to actually add a new to-do. To do so, I'm going to find the label we had already added, and I'm going to give it an additional property called submenu. So submenu, like so. Remember that the submenu is a reference to the collection of all the different buttons that are going to live inside of this dropdown. So the submenu is going to be an array that also contains a list of objects. So notice how we're kind of getting this nested structure for the template. We have the overall array that contains objects. This top level describes each of the separate menus we want to have. And then inside of each of these menus, so in this case inside of this label or this file one right here, we have the submenu property, which describes the list of buttons that should be placed inside of this particular submenu. So for right now, let's just get a simple label to appear on the screen, or a simple button to appear on the screen. I will define an object, and then inside of here, we'll define the label property and assign it the text new to do, like so. Now if we restart our application again, so I'll go back over to my terminal, I'll restart the app, and up at the top, I can hit Electron and I'll see the text new to do appear. Now do notice that on OS X or on Mac OS, we don't really see this label for file anywhere, right? Like that file label is being just merged directly into Electron right here. But if you're on Windows right now and you're watching these videos, chances are you are correctly seeing the first menu button appear with the text as file. And so this is another big gotcha in the world of Electron when it comes to cross-platform menus. So by default, when you're on OS X, the first entry inside of this menu template right here will be kind of adapted or absconded or kidnapped into the overall application menu, or the button at the top that is labeled after the name of your application. So in this case, Electron. To get around that, we really just need to add in a second menu option. So if I add in an empty object here, this is just a for example, I can then restart my application. And now correctly on OS X, the file appears separately and the Electron button no longer has anything, because we had said, oh yeah, the first button up here, just assign that an empty object. In other words, I don't really want any options to be available inside of there. Now, of course, as you might imagine, if you run this code on Windows, the result is going to be that you have really an empty nothingness and then you see the file menu. So we need to figure out a little bit more clever way of figuring out whether or not we want to put in this extra option depending on whether or not we are running our code on OS X or on Windows or on something else. For right now, I'm going to remove this option entirely. And I think we'll take a quick break and then come back and talk a little bit more about how we can handle some of the cross-platform nature of this application and do a little bit more intelligent checking of our current platform to figure out how to deal with our menu template. So let's take a quick break and then come back in the next section. In the last section, we ran into a little bit of a gotcha around the way that the menu bar behaves. When we're on OS X, the first menu option that we define inside of our menu template is automatically merged into this Electron button. The text Electron up here is coming from the name of our application. If you're on Windows, however, you will correctly see a separate menu item with the label of File and then the label of New To Do inside of that menu. So it'd be really nice if we kind of addressed this dissimilar behavior on each platform. Like, I would really enjoy it if we could show the correct menu template on OS X and then show a slightly different one when our application is running on Windows. To do so, we can add in a little bit of a check to see what operating system our application is currently running on. And depending upon the current operating system, we can set up our menu template just a little bit differently. To figure out what operating system we're currently on, we can have a glance at an environment variable that is maintained for us by the Node.js runtime. So let's take a look at this. At the command line, I'm going to run the command node by itself to enter the node REPL. So inside of here, we can put in any type of JavaScript we want, and it will be immediately processed, and the result will be printed back out to us. Inside of here, we can run the command process.platform. This will return a string that gives us a little bit of information about the current operating system that we're running on. The string right here of Darwin is referring to Mac OS. And so you might be curious, well, why is the Mac OS platform referred to as Darwin? And the answer is that Darwin forms the core set of components upon which Mac OS, iOS, watchOS, all these different platforms are actually built upon. And so Darwin is a reference to the underlying operating system that Mac OS is really built upon. So in practice, inside of our index.js file, we can add on a check to look at the process.platform variable. If this is equal to the string Darwin, then inside of here, we can make some additional changes to the menu template. In this case, I would like to add on an additional menu option to this object. So we'll say menu template, and I want to add on an additional object or an additional entry at the very start of this menu template array. To do so, we can use the built-in array helper called unshift. The unshift method right here takes some argument and then it adds it as the first argument to the targeted array, which in this case is the menu template. So inside of here, we could say that we just want to pass in an empty object. Now when we start our application back up again with npm run electron, the first menu option up here, electron, is completely empty, and instead we have just file by itself. And so this is going to work identically on either OS X or on Windows. So it behaves much more in a consistent, or it behaves in a much more consistent manner across each platform. Okay, so this is looking like a pretty good place to go. The next thing I want to work on is putting an actual useful menu item inside of that dropdown. So inside of this file thing right here. Right now we can see new to do, but when we click on it, of course, nothing happens because we haven't really assigned or associated any behavior with it. Our application doesn't quite yet have the ability to add any new to-dos, so I was thinking that maybe we could set our sights just a little bit lower and say that maybe instead we implement this quit button right here. So I want to add in a button that a user can click to quit the application entirely. Let's figure out how we would address that. Back over inside of our menu template, I'm going to find the section for our file, and underneath the submenu array, I'm going to add an additional object. We're going to give this thing a label of quit, and let's restart the application and just make sure that it's appearing on the screen correctly. So now when the app boots up, we've got both new to do and quit. Perfect. So now we need to assign some functionality that will execute, or some code that will execute whenever a user clicks on this quit button right here. To do so, we can define another property inside this object called click. Click is going to be a function, and as you might guess, it will be invoked whenever a user clicks on this button right here. So inside of this, we can look back at our app object and then call the quit function on it. This will cause the application to just quit entirely. So the instant we click on the quit button, boom, that's it, Electron's going to close out. So let's test this out now. So we'll say npm run electron again, restart the application. Now we can go up to File and Quit, and everything closes out. Okay, so that's pretty much it. Not that bad. Remember that in practice, as soon as we start to define our own application menu, we have to go back and redefine all this default functionality that we had out of the box with Electron. Now in practice, again, you really don't want to show your users the buttons to say open the developer console or reload the page or anything like that. So usually you're going to end up going back and adding in this additional functionality anyways. Let's take a quick break, and then when we come back, we're going to talk about one last thing around the quit button right here. And we're going to make sure that there's still a hotkey assigned to it so that a user can either go to File, Quit, or just press Command Q on their keyboard to also close out from the application. So let's take care of that in the next section. Now that we can open up the dev tools inside of our Add New To Do window right here, we can resume with our debugging process to make sure that inside of this form event handler, we can watch for the inputs value. So back inside of our application, we'll open up the new Add To Do window. I'm going to give myself a little bit of space to work with. I'll open up my dev tools, and then we'll go ahead and put a to-do in, and then add it. Okay, so this looks good. Now we have the ability to pause an execution of our code. So here's our debugger statement right here. And here's the full line. Very good. So remember that the goal right now is just to make sure that we can get the value out of the input. Of course, we could probably do this without using the debugger, but really I wanted to make sure that it was clear how we could add the functionality for the debugger back into our application. So I think that what we can do here is reference the document. We'll add in a query selector to get our input. So there's our input right there. And then we could read the value out of it by referencing value. Very good. So we'll take this value right here. Oops, we'll take that value. Okay, I'm gonna stop trying to highlight it. Good enough, you see the value. We're gonna take that value and we're going to use our IPC interface to send it over to our Electron application, where the value should then be forwarded on to our main window. So back inside of our code editor, I'm going to remove the debugger statement that we have in here right now. We'll add in document.querySelector to get the input, and then we'll get the value out of it. Now I'm also going to import, or I should say require in, our Electron helper, and then grab the IPC renderer off of that, which we're going to use to send our event back over to the main Electron process. So we'll say const electron, electron, let's require electron. Then we'll destructure off the IPC renderer, which is what we use to send messages back to the running app process. That's going to come off of the Electron object. And then inside of our event handler, let's store that value on a variable in here. We'll do a little bit of destructuring just to clean up the code. So I'm going to destructure value off of just query selector input. So I'm going to drop off the last value here at the end. Then we can use IPC renderer dot send. Remember that the first argument is going to be the event name. So I think that in this case we'll say to do add, and then we'll send along the to do. Cool. So I think that looks good. We can now flip on over to our index.js file, where we will set up our IPC on that side and make sure that we receive the to-do add event. So back inside of index.js, I'm going to find right above the menu template. So right underneath create add window, I think that'd probably be an appropriate place to locate this additional code to listen for the event. So right here, we need to set up another listener on our IPC main object. Just as a reminder, let's pull up our diagram. Let's see, here we go. So whenever a process sends a message back to Electron, we use IPC renderer.send, and then on the Electron side, we receive that message with IPC main.on. So we need to first import IPC main, and then we can set up our event handler on it. So at the top of the index.js file, we'll destructure off IPC main from the Electron object. And then back down in the area we were just working with, we'll say IPC main.on. The name of our event was to-do::add. So to-do add. And then we'll add on the arrow function that will be invocated whenever this event is issued. Remember that we have two arguments inside this event handler. The first is an event object, which tells us a little bit about the process that just issued the event. And then the second is the actual data that got sent along, which is our to-do. Now the next thing that we have to do is take that message and send it back to the main window this time, because that's where we want to actually reflect the message. So to do so, we'll reference mainwindow.webcontents.send. Remember that we've already set up the scope of main window correctly, so we had defined it ahead of time. So we don't need to do additional work around that thing. We can just reference main window directly. So we'll say main window.webcontents.send. I think that we can keep the same event name of to-do add. I don't think that we really need to rename the thing when we send it over to the main window. I think that to-do add is still a totally appropriate name. So we'll just stick with that. We'll say to-do add. And then we're going to send along the to-do as a piece of data that we're trying to communicate over. Okay, so I think this looks good. Let's give it a shot and just make sure that we've gotten this far correctly. I'm going to restart my Electron process in the terminal. I'll open up my new to-do window. I'll enter in my to-do and hit add. Okay, so presumably at this point in time, the IPC render is working the way we expect, and we are communicating this information over successfully. But you know, one thing that's kind of awkward about this flow right now is when we hit add, it'd be really nice if we could just automatically close this window right here. Like, we're not really doing anything else with it. Let's just dump it. Let's just get rid of it so the user doesn't have to click add and then very laboriously close the window manually. So when they click add, that's it, they're done, close that window. So let's take care of that challenge inside the next section. Now that we have the ability to show a brand new window to our user, I want to take some time to work on an HTML document that will display inside of this brand new add window right here. I'm going to open up my File Explorer over here, and I'm going to make a brand new HTML document, which I think we'll call, how about add.html? I think that'll work fine. Inside of here, we'll put together a little bit of boilerplate just to get ourselves started. We'll do our head tag. We'll do a body tag. Inside of the body, I'm going to place a form that's going to request that the user enters a to-do. So we'll give it a label of enter your to-do. We'll add in an input. For right now, we won't assign any additional properties to it. Remember that last time we made an input and assigned stuff like a type of file and stuff like that. This time around, we can just use a plain input because it will be defaulted to be of type text. Now there is one option that I'll pass into this thing that I think is a nice thing to have. That's the autofocus option. Autofocus right here will allow a user to just immediately start typing, and the text that they enter will be put directly into this input. We'll see what it looks like in action in just a second. I'm also going to wrap these label and the input itself in a div, and then place a button right underneath that. Just to be clear, I'm using the div right here so that the button does not end up on the same line as the label and the input. Without the div, all three elements would appear on the same line, which just looks a little bit nasty. Okay, we'll give the button a type of submit, and we'll give it some text of add, like so. Okay, I think this is enough to get started, at least get it to show up inside of our application. Let's go back to the index.js file and make sure that the new browser window that we're creating, the add window right here, loads up that HTML document that we just created. So right underneath the new browser window definition, we will call add window, and then we will tell it to load up this brand new URL. So the URL for this new page that we just made. So we'll say, look at file, and this is going to be an ES6 template string again, so do make sure you use the backticks here. We'll place the $, curly braces, look at the current directory, dir name, /add.html, like so. Okay, I think you can guess what's next. I think it's probably a good time to test this out inside the browser. So let's do that and see how we're doing. We'll do npm run electron. We'll go up to File, hit Add New To-Do, and yep, we're prompted to enter a new to-do here. Notice the autofocus in action. So this input is automatically focused, and I can just type in some stuff, hit Enter to add the to-do. So it's just a nice little enhancer for making sure it's easier for a user to add their text into this thing. So it looks like we're going down the right path here, but there might be a little lingering issue or two. Remember that when we started working on this application, I had said that I wanted to focus on some of the polish and some of the gotchas inside of Electron. So although we are making really good progress towards getting a list of to-dos to appear on the screen, there's still a couple of really weird oddities as well. So I want to show you some really interesting things right now. I want to show you what happens when I close this window. For some reason, the to-do button still, or the to-do window still lingers around. I don't know about you, but I kind of feel like when I close the main window of the application, I would really, really expect to see the entire application quit out. Like when I close that main window, that's kind of it. Like we're not really giving our users the ability to bring that window back up in any way, shape, or form. Like there's no options over here for opening that window back up. If I click on Electron down here, I can't add the window back up. So clearly it looks like there's maybe a little bit of an oddity there that we should think about a little bit and figure out how we can solve that. So I think that maybe we should take a quick pause from working on this add to do functionality and think a little bit how to solve the case in which a user starts to add a new to do and then closes the window behind it. So let's investigate that starting in the next section. We're now going to change our focus over to the menu option for creating a brand new to-do. So remember what we want to do exactly with this new to-do. When a user clicks on that button, I want to show them a brand new little window that's going to prompt them to add in some new to-do and then click this submit button right here. So really, we want to tie this click event right here to opening a brand new browser window, separate from the current one that we're already showing on the screen. I think to get started, the best thing to do is going to be to set up a little bit of additional code to create a second browser window, just like the one that we already have right here. So I want to have a little snippet of code that will, on demand, create a new browser window and load up a new HTML document, different than the one that we currently have. After we put that snippet of code together, we can then prompt it to be called whenever a user clicks on this new to-do option right here. It's definitely, I would definitely expect that a user will be able to click on this new to-do button several times throughout the course of this application. And so I think it would be a good idea to place this code to create the new window into a standalone function. So we can easily call it as many times as we want from wherever we want inside of our application. So to handle that, I'm going to create a new function right above the menu template. I'm going to call it create add window. So we're going to create the window that's going to add a new to-do, the add window. We'll refer to it that way several times throughout our code. Remember what we had to do previously with the browser window that we created? We assigned it to a variable that had been already initialized at the top of our file. Remember that we did this to handle some scoping issues throughout our code base. Whenever we create a browser window, it's usually pretty likely that we want to create or we want to access that variable inside of other functions inside of our code base. And so I'm going to choose right from the get-go to initialize that variable at the top of our file as well. So we'll say let add window like so. Okay, so now we'll focus on creating this new window inside of the create add window function. I'll say add window is going to be a new browser window, and we'll pass in our options object. Now notice how this time around, the window that we're attempting to create is definitely markedly smaller than the larger one behind it. So this time, I think that we want to spend a little bit of time to figure out how we can size this window appropriately. Maybe just shrink it down to a smaller size. To set the height of this window when it's created, we can pass in some options to the configuration object that we pass to the new browser window constructor. Two options that we're going to use to specify the height and width of this window are, as you might expect, width and height. Width and height take pixel values. So in this case, I'm going to say 300 pixels wide and 200 pixels tall. One other property that we're going to specify this time around as well is the title property. This will be used as the title of the window when it's showed to the user. And it's just going to give them a little bit more context and allow them to figure out exactly what's going on. So we'll prompt them by saying add new to do. Okay, so this definitely looks good, at least enough to test for right now. Let's go back to our submenu option of new to do and make sure that whenever a user clicks this, we show them or we run this function to create the new add window and display it to the user. So I'm going to find my label for new to do. I'm going to expand it out to give myself a little bit more space. I'll add in a semicolon, don't forget that right there. And then right underneath it, I'll add on my click handler. So whenever someone clicks this thing, I want to run that function that we just created called create add window. Okay, let's give this a test and make sure we're going down the right path. Back in my terminal, I'll start Electron back up. Uh-oh, looks like we got a little bit of a typo somewhere. Yep, my bad, I put a semicolon in there. So after the title, I put a semicolon. Sorry, my mistake. Talking and typing can be tough sometimes. I'll start my app back up. Okay, so here's my app. And now when I go to File, I'll click on New To Do, and I get my Add New To Do window appearing on the screen. So this is the title in practice right here. Here's the title. It says, hey, add a new to do. That's what you're supposed to do in this window. Now, of course, I can close this window out and go back to doing everything that I was before. I don't necessarily have to enter a to-do right now. Okay, so this definitely looks like a good start. Let's take a quick break, and then we'll come back and create a new HTML document that will be displayed inside of the add window object to prompt a user to enter in some text to use for the to-do. So I'll see you in the next section.